turn it on over to Jay Scheevel from Grand Junction, Colorado. Take it away, Jay.
Okay, well, I'll correct your pronunciation. It's Scheevel, and that's because I got Theo Scheeper on from South Africa, so he'll appreciate that. He's the only one that would pronounce my name properly. Anyway, I'll give you a quick rundown. I started building this airplane in 1984. So I think I may have been one of the first kits that got blue foam instead of orange foam. The rest of the people had orange foam. And then I met my future wife and had an entire family and sent them off to college and finally finished the airplane in 2018. So it did a lot of moving around and not a whole lot of building for the interim time. But if I had to guess, I would say if I built steady on it and did the same things I did now, it probably would have taken me about 7 years or 8 years because I did a lot of variations, much to Jim Mazel's disgust. But first I have to tell you why I did most of the mods that you're going to see. The Quickie has a fairly limited mission, and I wanted to expand that a little bit, knowing where I would be flying it and what I wanted to do with the airplane. So rather than change the airplane design a whole lot, I just kind of made some modifications that allow it to do what I wanted it to do, and it seems to all have worked out. So it wasn't just for the purpose of making Jim mad. But anyway, let me share my screen. And all right, so you should be seeing my airplane. It's in a little state of disrepair, not disrepair, but I was working on some stuff in the cockpit. So I'm going to start this video and then I'll just pause it when I have more to say than the video is showing. And before I start, if you look up here on the wing, you'll see the seat cushion is out of the airplane and there's a fire extinguisher up on the top of it. That's where I keep my fire extinguisher. I know we had that discussion last week. So I'm going to go around to the front of the airplane and show you there's a whole bunch of holes in this airplane. They all have a purpose. So these intakes, the classic intakes next to the spinner, those are just cool the cylinder barrels. And these other intakes down here that's a dedicated inflow air to radiator on that side. And there's one on the other side also for water-cooled heads on this engine. And then I made use of this, which is the original O200 carburetor air intake. That is a dedicated airflow that goes to the oil cooler. I'll show you where the air goes into the engine for the carburetor intake. That's right over here where you see these louvers. So this is out the top on the engine. You can see it's a 6-cylinder engine. What's exposed here are the water-cooled heads. I had a buddy of mine, I powder coated those valve covers and he painted the little bird on there for me. Then you can see the plenums that go across the cylinder barrels only. And then here's the plumbing for the water cooling, and then the radiator is down here, overflow tank. And then behind the engine is kind of tight, but I've got a B&C alternator that's aftermarket, belt driven.
Kind of tight.
And then that scat tube coming down is for the air intake to the carburetor. What you see here is the flywheel on the back, and then I'll point it out in a little bit, but I've got one electronic ignition. That's the coil up here. And then I've got one magneto type ignition. Behind this engine mount brace here, that's the original air box from the original Quickie kit. And what I've done is I've run the axle for that air box through the firewall. So this is the engine air intake. This vertical scat right here is going down to the heat muff. And then there's another horizontal one coming across here that goes down to the carburetor. So it gets that, I took that air box off of the engine itself and mounted it to the firewall. I'm going to pull off the plenums here. These just slide into place and they're held down by the upper half of the cowling.
Very nice fit there, Jay.
Thank you.
Yeah.
What I did, there's kind of a rivet seam you'll see down the middle of that. That plenum originally covered the entire cylinder on the original Jabiru, and I just cut it about 1.5 inches out of it and made it narrower just to cover the barrels. Now this is the lower cowling, and what I've got here is, this is the plenum that goes up and surrounds the radiator, and it's the same on both sides. So I have two cooling systems, one on one side of the engine and one on the other side. So it's sort of semi-redundant, I guess. But that air does not mix with any other air under the cowling. And I'll show you in a minute here. I've got some cowl flaps on the bottom so I can adjust the rate at which air goes through. So that's the radiator right there. And there's that vertical scat tube coming down to the heat muff. Sam will probably recognize that heat muff because I bought it from him. Now this is a cooling fin right here for the electronic ignition computer, which is mounted on the top of that plenum. And there's the coil for that same ignition system. It still goes into the distributor, and a distributor is what runs the spark. So if I went to an electronic ignition, I'd take off these distributors right here and do it like some of you other have done it. This is the starter plug stud. And that's the this is the back of the alternator, and then that goes down to the carburetor. And that's up on top of the engine is a starter and an oil separator. So this is the other side radiator. It's a little cleaner over here. This plug right here is running my EGT and CHT probes into a plug that can be taken off at the firewall. And then down below the engine, we're going to go down below the engine now. Terry advised I shouldn't use that heat wrap, but I need to keep heat from under the cowling, so I have it there. This is the intake for the oil cooler. And again, it's a dedicated flow directly to the oil cooler and then out the back of the cowling.
Tell us about that exhaust. Where'd you get that exhaust built?
That exhaust was what came with the engine, actually. It's a 3-into-1 collector, and that's where the slip joint is. But the engine itself actually comes with those downpipes directly from the factory. I think the collector was made for the Sonex people. That right there that you were just looking at, this thing is the cowl flap on the back of the radiator. And it's run with a servo from inside the cockpit. This is my nose gear. And now we're going to look up behind the engine from the bottom. So I made this little plenum down here just to spread the airflow out before it goes into this throttle body. And there's a regulator here mounted to the firewall that runs the fuel through. I've only got about 4 inches of fuel line forward of the firewall, so that it's not a real problem with vapor lock. This is the a bell crank that I built for running the throttle body. So you can see how it works. The control from the cockpit comes in up here, and then it just translates that to the throttle body. The throttle body is very simple. It's just a gate with a spray bar behind it.
Why did you use a bell crank there instead of just the push-pull?
Well, I use the push-pull, but it has to go the opposite direction. So
yeah, as soon as I asked that, I realized.
If I had brought it through the other side, like Jerry did, I would have gone straight to the throttle body. So now I'm going to start walking around the airplane a little bit this way. One thing I changed is the way the elevator meets the fuselage here. This is not shaped unlike what Sam has on his, but this is a vertical panel that comes backward from the radiator, and it's hollow in behind there. So I run my cooling air, cockpit cooling air through that like a plenum. And then this is also hollow. And so I have this panel, you take that panel off, and then you can slide the elevator in and remove it. And the reason I did this is because it gives me a vertical wall next to the elevator. So any elevator deflection is going to have a vertical panel next to it. And then, so that's deflected down and then back up. So, and then it's sort of fares the flow backwards from there. And the other thing I changed was the center elevator mount or elevator pivot. And it looks like this from the outside. You see a strap there that goes all the way around, U-shaped strap. And then inside of that is a nylon bushing. And it wraps all the way around the torque tube. There's no break in the torque tube. So I put this diagram here so you can see how it works. I put a phenolic block that mounts to the spar. And then this split bushing here goes all the way around the torque tube. And then the stainless steel strap bolts through the phenolic block. So it's more like if you've ever seen the Waco elevator torque tube, it looks like that.
And why did you do this, Jay?
Well, I didn't like the idea of having a hole in the torque tube, both from corrosion standpoint and also from a structural standpoint. So I built it this way. Actually,
you know, we had a fatality several years back. The fellow was on his way from Florida. We didn't really know him, and he wasn't too far from the event, and his right canard failed in flight at that area. And it was investigation did reveal that he had cut out a lot more of that elevator at that point than he had than the plans called out. But
there's also been a couple of people have found cracks in that stud, which can happen if the stud is not quite parallel with the pivot. You're putting stress on it every time you move it. So I just didn't like the idea. So this allows me to actually pre-flight check that. This is the wheel. I went to 505s on the main gear, and I see I've developed a little crack there. That's the original gear leg right here is got a fairing on it. And the fairing, you can see my brake line comes down through a gap. It's like a triangular tube in the back of the fairing. but the reason I did this is because if you look at the airflow over the gear leg is not aligned properly. You can see this is looking straight forward on the axis of the gear leg, but there's the canard. So you've got flow coming down off the canard and it comes across the lower gear leg. And it can be as high as about 13 degrees off from the gear leg orientation. So that's a big drag point. So I did like what the Long Easy guys do, and I built a fairing that goes up and across, and you can see it changes the angle of incidence. The wheel fairing fits across that transition so that it covers the entire brake assembly and in transition. So it's pretty clean aerodynamically. This is the bottom of the fuselage. So this is the gear leg coming in here on the left. And instead of a speed brake, I just have an access plate that screws onto the bottom. That allows me to take the gear leg off. I'm going to fill up these gaps with a silicone bead, but I haven't done that yet. This is the bottom of the airplane. That's a main tank fuel vent or fuel drain. I stole this idea from Bob Malachek. He had stainless steel plates on the bottom of his canard, and I did the same thing. They're really nice. It's really easy to keep clean, and it has a heat shield, so I can have my exhaust pipes come out a little bit shorter.
How thick is that stainless?
It's real thin. I bought it in the fly market at Oshkosh, so it's a stainless. It's the same stainless you'd put on your firewall, but then I put a piece of fiber frax behind it, and then you can see the each of the fasteners is floating, so if it expands and contracts, it doesn't stress those fasteners. This little thing looks like a hole is actually a plexiglass window, and that's for the infrared laser altimeter that I have. It's a precision altimeter, looks straight down, and I have that plumbed in so it actually calls out the altitude to me on short final. Now I'll play. I think I've got that in the audio on this thing. I'll play that for you in a minute. So these panels come up and they wrap around underneath the firewall. So I've got kind of a fireproof belly on there. And then these fairings are the last thing I made for the airplane. That's the gear leg fairing there. And you can see what the fairings look like when they're installed on the main gear right here. That's my ram air. And then this other little tube right here is my header tank drain, sump drain. So I put a little piece of safety wire on my fuel tester, and I can slide the little wire up in here and hang it on that and then reach in the cockpit and drain fuel out of the header. Okay, now we're going to look inside the airplane a little bit. I'll explain what these doors, how the doors were made in a minute, but I was doing a little electrical work in there. This is how I get in the airplane. I step on this towel, and then the seat just lays down underneath me, and I stick my feet down in there. This is behind the pilot's seat. I have my accessory bag there. It's got like things to clean the wings with and stuff like that. I have a tool roll on the other side. This is my oxygen. The tank goes in above the wing, and the regulator sticks out just between the pilot and passenger. This little box right here is my audio box that calls out the altitude from that precision altimeter. And you can see here's the oxygen cylinder back in here. It's fastened in there with a,
Hey, what's the range on that altimeter? How high can you be and it still works?
it starts calling out altitudes at 80 feet. So you basically just flip it on final, and then you listen for 8. When it calls out, it calls it out 8, 7, 6, 5, 4, 3, 2, 1, and then it says 5 and 2. So the 8, 7, 6, 5, 4, 3, 2, 1 is tens of feet. And then the 5 and the 2 are 5 feet and 2 feet. So I'm sort of holding it off at 2.
And what is the manufacturer? What is the name of that?
I guess you'd have to call me the manufacturer. I bought this unit and I had the guy customize the firmware. This is actually it's a digital voltmeter that has an audio circuit that will call out voltage to you. And I had him modify it so I gave him the voltage range that was coming out of the altimeter, and he modified it to call out the numbers for me.
And who manufactured the actual altimeter itself then?
That was a South African company called Lightware.
Okay.
It's originally I had it set up with just this gauge right here. And everybody told me, well, you're not gonna be able to look at that when you're landing. And I said, yeah, I am. It's right in my sight line. But they were right and I was wrong. So I went with the audio thing after the fact. But it does have a readout here with your altitude on it if you care to look, but I don't care to look.
Yeah, your head belongs outside the cockpit on takeoff and landing. No other.
Yeah.
Purpose. Yep.
So let me just go back just a second. I'll show you this. This is my, we're going to swing forward now. Look at the panel. So I have a Skyview EFIS there in the center, and then my traditional steam gauge is there. And then this is all my engine stuff over here. So I have a primer, which also works to override the regulator if the regulator fails in flight. This is carb heat, dual ignition, and then the starter button, mixture, and throttle. So everything's on my left hand over here. And then that other handle below is my reflexor control. And then I stole this idea from Sam, putting that extra mechanical gauge in the tank.
Where did you
So
get
this
that,
is-
by the way? I got mine from a aircraft junkyard.
I got it from Spruce, but then I modified the lever arm. This is this is my reflexor. This has turned out to work really well. It runs with a cable, actually a cable over a pulley on the back rather than the push-pull like most people have. This is the left side rudder cable coming back here. So it runs through the armrest. Both of those cables run through the armrest. And then this is where they go back. So these two cables run from the reflexor, and then this is the brake or the rudder cable going back. So I'll kind of show how that goes. It comes through the seat back bulkhead here. Got a guide pulley there for the rudder. And then the rudder cables go back to bell crank right here. And then this is the reflexor. You can see that there's two cables that go around a pulley on the back side of the bulkhead that run the reflexor right there. Then I built a tunnel that you can take off with wing nuts there that protects that torque tube from any luggage you might put back there.
Jay, which version of reflexor did you make?
Well, I made a kind of a custom one, but it's basically Paul Spackman's, it's not his design, but he did the engineering drawings. I used that, and instead of on the back, instead of having a lever on the back or an arm, I used a pulley. I don't have a good video of it because it's behind the tail cone. I didn't take the tail cone off.
Yeah.
Now this is a tie down and a tail skid. And yes, the tail skid has been used. So I made a little phenolic protector on there. I actually made 2 of them. I'm about halfway through one of them. So we're going to look underneath the tail now. And I added a panel, access panel right there. After standing with my head up in the tail cone for a while, I decided that wasn't something I wanted to do in the future. So I put that in there. And then this is my rudder cable assembly. So the rudder cable comes from the bell crank up front, wraps 3 times around this spool, and then goes back to the bell crank. So it's a single cable. And then there's a friction lock right here. And so it's really just a spool that runs the rudder. And that seems to work really well. And it keeps the cables entirely inside the airplane.
Very interesting. That's a solution to my question of how to cut down wind resistance for those cables in the bell crank and all.
Yeah, you could do that on yours pretty easily. You could just, instead of running them outside, just redesign this to make a little tail.
Okay. Nothing is easy.
So we're going to look up inside here now. So this is the connector for my primary comm radio antenna that's in the tail. And it goes forward from there. There's the 2 rudder cables coming back. And then if you look on the aft bulkhead right here, you can see there's a kind of guide spool. Doesn't really bear any load. It just keeps the cables kind of in place. We can just stop it, and when everybody gets back on, I can start it up again.
You've still got another 3 minutes here. So.
Okay, well, I'll just keep going. This is the overhead beam that I put in there. And that vent right there, all that does is vent the avionics that are below the wing. That's my outside air temperature. And those 2 little bubbles there are venting the battery boxes. Then up on top, I've got some fairings here that the same idea as the elevator fairings. I have a slab wall on the inside edge of the aileron. That's something that doesn't exist on any others that I'm aware of. Just trying to keep the airflow laminar. And then up on top, oh, this is kind of interesting. I put a little overhang on the forward shell of the fuselage, and that's to keep the rain from going down inside the airplane. It works pretty good. And then I stole this from Jim Patillo. This is my exit air for my cabin. And it does get a lot of good flow. Okay, so this is the mod that I did to change the fuselage shell and give me more headroom. So what I did is I basically just split the fuselage, made a bunch of barrel staves out of it, connected it up, give me 2 more inches of headroom at the top and about another inch to the side. And this is how it went together. And then I made this overhead panel, which also gives some rollover strength. Okay, I'm just going to show a little bit inside the airplane on the passenger side. So this is my avionics master. I put a bunch of switches on the ceiling, and I flew the magnetic card compass, so it gives me more room on the panel. And you can see the C-beam that I built that is the overhead panel, and where the arms, swing over arms for the doors for the cockpit are. And then there's the panel again. If you look on the top, I've got a little slit up here. That's hot air. I can run heated air onto the canopy if I need to. Haven't needed that yet. And here's the video again. We'll go back. Now I'm going to look inside the back passenger's side. So I have this panel, which is this is the avionics bus. And then I have 2 battery boxes and 2 solenoids here that run. So each battery can run independently or they can run together. Also, I built a little plexiglass panel that fits over the batteries. So if you put something back here and it's rattling around, it's not going to short out your electrical system. And then each of those battery boxes, they're vented. So here's a vent coming through the wall, goes into the first battery box, and then there's a join that goes from the first to the second and then out the back. So there's air coming in to cool the batteries, but the batteries are sealed off from the cockpit.
So those are lead acid batteries?
Nope, they're EarthX batteries. That's why I built the boxes. They're lithium oxide or lithium potassium oxide batteries. This is my transponder. And then I have the radios mounted on the bottom of the wing right here. So there's COM 1, COM 2, and that's the aileron autopilot servo there. And then we're coming back to the front now here. And where this box right here is the intercom that's mounted in the seat back. And then that connector right there is a network connector for the Skyview system. So that's all the avionics are essentially behind the seat back. That's why I have these extra vents back here. Although I haven't noticed it getting hot at all, but I didn't want to risk it. Now I come forward, and in the forward part, this is the passenger's seat, fuel tank here. So I'll show you some of my plumbing. On the forward face of the main tank, I've got a fuel pump. I've got a fuel filter there, a shutoff valve. That valve is just used if I want to change the filter. I can just turn off that valve and I won't drain my tank into this sump here. So that's always open during flight. So that this is the torque tube, and I've got these rule-on bearings that I stole that idea from Jim Patillo and Bob Farnham. And I have my balance arms for my mass balance. They're mounted on the outboard rather than the inboard end of that torque tube. Puts them a little closer to the actual elevator surface. So I put these rule-on bearings in there, and then in order to do that, I had to cut a little bit wider hole. So I put these 2 1/8-inch aluminum backup plates on there. Okay, so this is my David Gall made fun of this, but this is my compact elevator trim unit here. And if I pull the elevator, you can see that it's It's riding on a rail with springs. And then this lower rail actually moves in and out on a servo. So that's how the elevator trim works. This is an extra fuel pump out here. Actually, it's my primary fuel pump. And it runs down into a T intersection here, and there's a check valve right there. So I can run gravity out of the header tank that goes this way, or when I flip on the pump, this gravity check valve closes and I pump directly into here. So I usually leave that pump on all the time anyway. Then this right here is the coolest thing that I ever saw. So I had to put it in the airplane. And it is a flow meter. And the way it works is like this. It shoots an ultrasonic wave through the fuel line. And it uses the Doppler effect to figure out how fast the fuel is moving through the line. So you don't put anything actually in the line. It just clamps on the outside of the line. And I thought that was too cool to pass up. This right here is one of the backing plate mounts for the engine mount. And what I did is I used eye bolts, and then I put a 3/16 inch bolt through each eye bolt so they're ganged together. And that way I can actually just put one wrench on the front side of the firewall and take that off without having to reach in back and hold a wrench on the back. This is a big capacitor to try to calm down any spikes that might come from the alternator. And then these are the two water temperature gauges for each side of the cooling system. Two comms here, and then the EFIS there. This little box right here is the readout for the fuel flow.
Why do you have two water temp gauges?
I have two independent sides to the cooling. So I have a left side and a right side. They run independently of one another. So these little slides right here control the servos on the cowl flaps. So I can close them all the way up or open them up depending on how hot this is showing each side to be.
How many servos do you have in this thing?
I don't know, I've lost count.
I bet.
So this is on the pilot side, and there's that's the elevator servo for the autopilot. Here's the two rudder cables. And then some people have asked me about this platform. I built a platform that bolts in that holds the rudder pedal assemblies. And you see some of the plumbing here for the ventilation system. And that's a mass balance arm. So this is the other side of the fuel line we were looking at. So this is the takeoff for the fuel pump. There's a fuel pump there. And this is the gravity feed out of the header. And then this is the engine management box for the dynon. And there's a bunch of other electronic stuff under there too. That's the regulator for the system. Oh, these are, let me just go back here a little bit here. You asked how many servos I have. These boxes up here are the controllers for various servos. And then that's the main bus for the electrical system. And now I'm sitting in the airplane with all this stuff turned on. That's the fuel flow meter. You can see it's reading 0 because the engine's not running. but you can kind of scroll through it and then it shows that's a totalizer. So it shows how much fuel's been used.
What are the units for that?
That's in liters. This thing that I just flipped on here, that's I don't know whether you can hear it or not, but hold on a second. So that's in liters, 14.1 liters. Then I flip this on. This is the radar or the laser altimeter. So that's what I hear in my intercom. And it's at 0 altitude right now, so it went all the way down. Okay, now this is with me flying the airplane. So I'm using six gallons per hour right here. And
so it switched units. It switched units from liters to gallons there.
Well, it allows you to select gallons per hour as a rate, but the totalizer always works in liters.
Okay.
So this is me flying, and the reason I show this is you see my knees up here. My knees are off the rudder pedal, and my heels are sitting on the spar. So the reason I built the panel like this is so that I could bring my knees up in flight. So I don't have to have my knees always underneath the panel. It's kind of nice just to relax. This little light right there tells me that my starter is armed. So it's green if the starter is not armed. And that's pretty much the whole thing.
Holy smokes. I think you get the award for the most stuff crammed into a little airplane.
Oh, one other thing. See these up here? Those are little computer fans. So they pull air behind the EFIS. Anyway,
How tall are you, by the way?
I'm 6'1". That the split canopy and doors and all that stuff were the result of me riding enough times in other people's quickies and having to put my head in like at the center like this so I didn't bump into the canopy. I decided I better change that, so I changed it.
Are you an electronics engineer?
No, I'm a geologist.
Wow.
I'm
How many
I'm a
elevator
music major.
balances have you got on yours then, Jay?
What's that?
How many elevator balance? Have you got two?
I've got
Balance weight.
two counterweights. One on the outboard of the passenger side, one on the outboard of the pilot side.
Okay.
And in fact, those actually serve as my inboard limiters on the torque tube. So what I do to take the torque tube out and remove the elevator is I just take the bolt out of the balance arm, and then the torque tube can slide inward.
Hmm.
How much does the plane weigh empty?
It's 760. Yeah. So Bruce's grandson even knows that's good.
Mine is 764 empty weight, so you beat me, Jay, by 4 pounds.
Oh, I 4 pounds is probably the error bar.
I've got that MT propeller, which is probably 37 pounds or so.
Yeah, about the propeller, I have a Prince propeller, and I kind of bought it as a test propeller. I thought it'd be good in climb and everything. It turns out to be, it's just about right, perfect. for this airplane because I can get it up to about 3,200 RPM, which is 100 shorter red line, straight and level at my altitude. So I think, you know, with the fairings on and everything like I have it now, I think if I get down about where Sam is, I can probably turn it up to about 3,300 and get to max speed. And it still gives me 2850 static, and I can get off short at high altitude. So I think it's just about perfect. It's
Have you done
it's
it? Have you done
50
any load testing with sandbags in the right seat yet at your altitude?
I have. I've got 3 50-pound shot bags that I strap into the right seat, and I've put in 2 of them, and I've kind of been dragging my feet putting in the third one, but I'm sure I can get off with a third one in there. So that's 150, even though I'm about 5,000 feet pressure altitude. The key for me is not climb rate. The key is I have to accelerate to 80 to get off. And so it's really an acceleration issue rather than a climb issue.
Yeah.
But I just like flying at light too much to kind of do that. My guess is I won't fly with a passenger out of my home strip. But I get to a longer strip, I'll probably try it.
What are your cruise speeds?
What are my air speeds?
Yes.
It's pretty similar to a lot of other people. I'm on short final at about 90, over the numbers around 85. Plane quits flying about 72 or 73 in terms of holding off the runway. So I try to put the wheels on the ground right around 75, but I'm not thinking about that. I'm just doing it by feel. I know that for a fact because I can download the EFIS after the fact and look at it. But generally what I do is, you know, at 90, I'm doing about 600 feet a minute descent. And then I'm putting the wheels on the ground below 80. And then, you know, I can stop on my 2,800 foot or 2,600 foot long strip. There's 600 feet of grass on one end, but I've only been into the grass once. So, and I don't usually I'm turning off at the fuel island. So I can get stopped pretty quick, maybe less than 2,000 feet.
What is your climb rate?
Climb rate depend on density altitude. My density altitude is always above 5,000. So climb rate is around 600 or 700 feet per minute at 1,100 pounds gross weight. And I can climb a little bit faster if I get going faster, about 105, 110 mile an hour. I can see maybe 800 feet a minute. So it's pretty good. My cruise now, like what I was showing here, where I'm doing 6.2. Maybe I can go back. Is the screen still on?
No, I took it off so we can
Oh,
just see here, but I will put it back. All right.
okay. I think I have to hit share. All right. So let's see. Here's in flight. So I'm right at 149, 150 indicated. So my true air speed's 162 and I'm burning 6.1 an hour. My RPMs are 2960. So as it turns out, if you go by fuel burn, and I've got it leaned out pretty good here, fuel burn is, if you multiply that times 10, you're going to get the percentage power. So I'm at 61% power, indicating about 150. So that's pretty good.
Mm-hmm.
And if I go to like 3,300, I want to make sure it's not too lean. So I push it full rich and it'll burn about 8.5, 9 an hour.
What's the power output from your engine, Jay?
At sea level at 3,300, it's supposed to be 120 horsepower.
Okay.
But I imagine the most I can milk out of it at my altitude is maybe 90. 95 maybe.
Jay, you have oxygen in there. What's the highest you've had it?
I've had it up to 13.5 in cruise. So I can cruise, yeah, I can get a true airspeed cruise over 150 at 13.5. But that happened to be a hot day, so density altitude was 15,000 at that time. But it'll get me over the mountains. It doesn't climb very fast when you're up there, but it still climbs. So I don't know what service ceiling is, probably 18,000, but I'm never going to go up there.
Oh, let's find out.
You want me to find out?
Yeah, sure.
All right, I'll find out. But I just wanted to make sure it met the needs that I have up here. I do have some mountain passes that I fly over that are at 12,000 feet. So I like to have minimum 1,500, 2,000 feet over the top of those.
Sure.
I generally avoid those, so.
Say, Jay, would you feel comfortable of going over to the other airport with a longer runway to put a passenger in? Would you do a passenger then?
Yeah, that's what I would do. If I was going to fly a passenger, I'd do it then. Right now, I can do the 100, probably do the 150 out of my strip, but the primary purpose for adding the more weight is not to show that I can get off with that. It's to show that I can handle the change in CG. So that's really what I need to practice is how the CG changes.
Yeah.
Because it does change quite a bit when you put the passenger in there.
Yeah, and using a reflexor.
Well, I use my reflexor and my elevator right now.
Yeah.
When I land, I'm full forward, nose down reflexor and full aft, nose up elevator trim.
Oh.
Richard's going to shake his head now because I told him, don't worry about the elevator trim till you've flown it a bit. But I didn't put the elevator trim in for a year after I flew it. So, but I like it that way now because I can come in a lot flatter and my flare is much more positive, much more firm. Speeds don't change at all. And when I cruise, I put a full nose down reflexor.
So do you use the reflexor to flare instead of the stick since you're all the way aft?
No, I just leave the reflexor where it is. And
then
the trim, and I leave the trim where it is. So I'm just using the stick for flare.
Have you just got 2 degrees max forward on your
On the
reflexor?
The reflexor, it's the standard is 6 degrees down, 10 degrees up. That's supposed to be the limit. But I actually do high speed cruise at 6 degrees down reflexor. And what that does is it gets me on the step because my wing is mounted with 1.5 degree down angle on it.
Oh.
So where most people would be using up reflexor, I'm using down reflexor. And everybody has a different wing arrangement. So, you know, everybody's mileage is going to vary, as Sam says. You just have to fly and experiment with the reflexor so you know where you want it to be. I have thought about emergency landing procedure. And I think with emergency landing, you really want to keep the nose wheel off the ground as long as possible to avoid flipping over, especially if you're landing in a soft field or something like that. So my thought is that just as the airplane touches down, I would be pulling full aft reflexor, full aft stick. So I'd have both hands the left hand on the reflexor and the right hand on the stick, and I'd be pulling them full aft right as the wheels touched. And that would get you as slow and as high an angle as possible as you start to impact the ground. And I'm not going to test that out, but that's what I would probably do.
If you've drugged the tail, you may have already tested it out a little bit. I've done the same thing, and I've got a scratch on my tail underneath from doing a really nose high attitude.
Yeah, I have that when I drug my tail, I may do that when I put all those sandbags in there, but when I've drugged the tail, it's been because I bounced the nose gear down and it bounced it back up and hit the tail.
Yeah. Yeah.
But
That's
I
what
do know
happened to
that
me, too.
my tail skid is plenty strong.
Yeah. Yeah. I landed too slow with my son in there, and it hit on the mains, and then it bounced and it hit on the nose and hit the mains again, back and forth, and it scraped it a couple of times. So I learned I was coming in too slow.
Yeah, that's why I threw some of the ideas out there about redesigning that nose fork, is that you have a bad combination. The main gear leg is really good. I mean, it'll soak up shock like crazy, but the nose gear is really stiff. So if you do drop it in, you get into that situation where the main just soaks it up, and then you hit the nose, and then it pops it back up, the nose back up in the air.
Yeah. Yeah.
So I'd like to see a softer nose gear if you could do that. But I was talking about mission earlier. One of the missions that I built into the airplane was to make it a trainer because I hadn't flown it before. So I thought, well, you're going to have some hard landings. So I put a lot of extra beef into the gear mounts, particularly just on that off chance, and I've tested it, but it's fine. It holds up. So
You probably explained it earlier, but I had a question on your rudder. The small diameter of the where the cables wrap around it.
right.
On my rudder, I think the horn is probably
Extended.
5 inches wide, something like that, maybe 6, maybe not quite that much, but that slows it down because of the geometry. Did you have a bell crank or something that I missed, or something up front that slows it down?
The bell crank I have is actually the horn that used to be on the bottom of that rudder assembly.
Oh, okay.
And I mounted it up front, and then my little spool in back is 2 inches in diameter. And so what I did is I put parallel rudder cables going back from the bell crank. So my rudders go to the 5-inch wide, and then in board of that on that bell crank, there's a 2-inch wide mount point for the cable that goes back to the spool. So it's exactly the same ratio as you have.
Okay.
And it works really well. I mean, I get full travel out of it. I have a fairing on there that shrouds the whole thing.
Yeah.
So it's kind of nice.
Very good. Very good.
If you do that, what you have to do is you have to drill through the foam in the rudder. And then I put the Nylaflow all the way through that foam. So there's like 12 inches of Nylaflow inside the rudder on both sides.
Inside the vertical fin.
Inside the vertical fin, yeah. So.
Well, we've got about 6 minutes.
Yeah.
Hey, Jay, any last words or thoughts that you would like to express, advice to builders?
Yeah, I would say don't do all the stuff that I did unless you really want to spend a lot of extra time building your airplane. Most of the mods that I showed, I actually built twice. because I built it once and I didn't like it, and I build it again. So, but the one I would say is probably worth the time and effort is the canopy. And I would say if you want more headroom, that's the only way to do it. But I would, that's the one that I think really improves the airplane in terms of flying long distance for people that are tall. If you're not too tall, it's not an issue. But if you're tall, I never did believe Gene Sheehan, you know, he's 6'5" or whatever, that he was comfortably flying that airplane.
I've, over the years, I've reduced my height by 1.5 inches, so I'm fitting a lot better than I did when I first flew it.
Yeah, that's the alternative, I guess.
I threw my pumps away, so I'm good.
Well, I did intend to actually have a split canopy from the very get-go, but I was not going to build the doors like I have. I had intended to make it where you had a forward fixed portion of the canopy and then kind of a girdle shell that would go open with the canopy openers. And that way you wouldn't have to worry about the front edge of the canopy lifting up on you in flight. But I think that would still work if somebody wanted to keep the same profile. But I have not seen anyone do it that way.
We're down to 1.5 minutes, Jay. I've got a question from David. How many hours to building hours? Do you have any idea?
Somewhere around 4,000.
Whatever that means.
Yeah.
Yeah.
That's the ones I was able to keep track of. You know, all the redesign time and all that stuff is extra.
That's 2 years solid work, full every day, isn't it?
Yeah. Yeah, you can't afford to buy my plane if I charged you by the hour.
And you couldn't find a buyer either.
Yeah, probably not.
Yeah.
But I love the plane. It flies great. That's the bottom line.
Good.
Jay, I want to thank you very much for doing this. It's kind of a unconventional way of presenting it. You're the second one. Mike Dwyer did this also, and it takes extra effort and all, but appreciate you doing it very much. And you guys I'm really glad you guys are showing up and watching these videos, and it's a good way to spread the community. So
Yeah, thanks for setting it up, Sam.
all right, everybody have a good day and stay safe.
All right.
And you guys, take
Bye.
care.
Thanks, Sam. Thanks,
Thanks, Sam.
Jay.
Thanks, Jay.
Thank you.